this WAEC question on galvanometer, it says a galvanometer with a full scale deflection of 20 milliamps is converted to read 8 volts by connecting a 395 ohm resistor in series with it. Determine the internal resistance of the galvanometer. Okay, let's quickly do this. Now, when approaching questions on physics, the first thing we do is to write out the parameters given on the question. So the first parameter we'll get from here is a galvanometer with full scale deflection. So the full scale deflection current is 20 milliamps. And since it's a voltmeter that we are talking about, so it will share the same galvanometer current. So full scale deflection current is 20 milliamps hour. 20 milliamps hour. And then you convert this to its standard unit. Standard unit for current is amps, not milliamps. So this will be 20 times 10 raised to the power of minus 3 amps. So the next parameter here is it's converted to read 8 volts by connecting 8 volt. That 8 volts there represents the voltmeter reading. V equals to what? 8 volts. And then by connecting a resistor, the resistor connected in series with the galvanometer is what? 395 ohms in series with it. So determine the internal resistance of the galvanometer. Internal resistance, small letter r, is what we are looking for. So having been able to list out your parameters, the next thing you have to do is to find out the formula concept that is suited for the question. So now here they are talking about a galvanometer that is converted to read a voltage. And then for a galvanometer that has been converted to read a voltage, what we have done in our previous video about galvanometer conversion to voltage is that voltmeter reading equals to what? Equals to galvanometer current, you open bracket, into what? External resistor or multiplier resistor, you call it series resistor, plus what? Internal resistance of the galvanometer. So since we are looking for this small r, we are going to make small r the subject of the formula. So this will be V divided by galvanometer current. That's, you divide both sides by I subscript G. So what will be left on this side will be big R plus small r. Then for small r to stand alone, you have to take this big R to the left. And that will be what? V over I subscript G. Since this plus R here is going to be what? Minus R, equals to that. Or you can write it this way, that R equals to V over I subscript G minus R. So having done this, the next step is to substitute. So let's substitute. Our R, small letter r, will be equals to, our V is 8 divided by I subscript G. I subscript G is 20 times 10 raised power minus 3. Then minus R. R is 395, which equals to 8 over 20 times 10 raised to power of 3. This 10 raised power minus 3, we take it to the numerator, it becomes 10 raised power positive 3. Law of indices. Minus 395. So this 0 from this bottom will cancel one of the zeros here. 2 zeros will be left there. and 2 here will cancel 8 here to become 4. 4 times 100, that's 10 raised power 2 is 100. 4 times 100 will give you 400 minus 395. And when you minus that, you get what? 5 ohms. So the value of the internal resistance of the galvanometer is 5 ohms. Thank you. The sample theory question from WAEC 2022. It says, the reason for having a large number of turns in the coil of a moving coil galvanometer is to, so having a large number of turns in the coil, what is the reason for that? This is a galvanometer. This is a circuit symbol of a galvanometer. And then recall in the construction of a galvanometer, this is the pin or pointer that is being connected to a coil that is movable. So this coil is placed on a magnetic field generated by 2 magnets. So now, based on theory of electromagnetism, when you place a conductor in a magnetic field and then you pass a current through that conductor, the conductor will experience a force. And that force depends on what? The number of turns of the conductor. Depend on the number of turns the conductor. Also depend on the strength of the magnetic field. Also depend on the current through the conductor. Also depend on the length of the conductor, and also the angle, the sign of the angle at which you place the conductor on that field. So with this formula here, it means that if you increase the number of turns, you increase the force experienced by the pin. So the answer to this question from this analogy, what do you think will be the answer? It will be B, to increase the sensitivity of the galvanometer, because when you increase the number of turns, that means the force generated will be high. That means the slightest current that you could have that will pass through the galvanometer will cause a deflection. So that means when you increase the number of turns, you are increasing the sensitivity of the galvanometer. That means it is as low, as smallest as possible the current will be, there will be a deflection because there is large number of turns. All right. Thank you. Wire question on galvanometer, example voltmeter. It says a student wishes to measure the potential difference across a resistor R. She has a galvanometer, G, and some connecting wires. What else does she need? Okay. Now you recall when in my previous videos when I talked about conversion of galvanometer to voltmeter, that for you to convert a galvanometer to a voltmeter, what you have to do is to connect a multiplier to it. What I say a multiplier means a resistor in series with it, and that resistor must be a high value resistor R. So the answer to this question is D. What she needs to do is to connect a high value resistor in series with a galvanometer to be able to achieve a voltmeter. 2020 on galvanometer. It says a moving coil galvanometer which gives a full scale deflection with 0.005 amps is converted to a voltmeter reading up to 5 volts using an external resistance of 975 ohms. What is the resistance of the meter? As usual, we have to first start by writing out our parameters from the question. So what parameters do we have here? Moving coil will give a full deflection with that. So what we have there is a deflection current or the galvanometer current, right? subscript G equals to 0.005 amps. Okay, which is in the standard unit, or you can still write it as what? 5 times 10 raised to the power of, if you move these points to 1, 2, 3, 5 raised to the power of minus 3 amps. So the next parameter is that converted to voltmeter up to 5 volts. So that means the voltmeter reading equals to 5 volts. The next parameter is external resistance of that. External resistance, capital letter R, equals to what? 975 ohms. Then the question is, what is the resistance of the meter? That the meter in question there is the galvanometer that points on a calibration. So what's the meter reading and that the resistance of the meter? So that's internal resistance of the galvanometer. That's what the question is. And then from the video we explain how to convert galvanometer to voltmeter. We arrived on this formula that V, that's voltmeter reading, equals to what? Galvanometer current, open bracket, multiply through with R, capital letter R plus small r. So since we are looking for small r, we'll make small r the subject. So to make small r the subject, this will be, we divide both sides by IG, I subscript G. What will be left on this side will be R plus small r. If we make small r the subject, what you have is V divided by I subscript G minus big R. So if you substitute your values into that, what will you have? Our V is 5 divided by I subscript G, which is another 5 times 10 raised to minus 3, then minus 975. 175. So we continue. This will then be equals to, if you take this 10 raised to 3 to the numerator, you have 5 over 5 times 10 raised to 3 minus 975, which equals to 5 divided 5, 1. So what 10 raised to 3 is 1000. 1000 minus 975, which gives us this minus that will give you 25 ohms. So the value of the internal resistance of the galvanometer is 25 ohms. Thank you. This WAEC question 2015 on galvanometer. It says when current flows through a moving coil galvanometer, the force exerted on the pointer depends on the I, strength of the current, II, magnetic field strength, III, length of the coil. Which of the statement above is are correct? So now they are asking us that the force exerted on the pointer, what does it depend on? So what will be your answer? So this is what will be my own answer. Remember, under the theory of electromagnetism, which says that the force exerted on a coil or on a conductor is directly proportional to what? The strength of the magnetic field, also proportional to the current through the conductor, also proportional to the length of the conductor, and also proportional to the sine of the angle of the conductor with respect to the magnetic field lines. So, having seeing this formula, you see that the force exerted on the conductor depends on the field strength, on the current, and on the length. So let's look at our this thing, the statement. They say depends on I, strength of the current, which is true. Strength of the current, which is true. Magnetic field strength, yes, it depends on magnetic field strength, which is B here, which is also true. Length of the coil, L, it depends on length of the coil, which is also true. So the three statements are true. So what will be our option here? Option D, I, and I. Thank you. Question WAEC 2011 on galvanometer. It says an ammeter with a full scale deflection of 10 milliamps has an internal resistance of 0.5 ohms. Calculate the resistance of the shunt required to adapt it to read up to 3 amps. Okay, so basically here we are converting the galvanometer to an ammeter. So I could just write the formula. We write out our parameter. Our parameter here says an ammeter with a full scale deflection current. So that means our galvanometer current equals to what? 10 milliamps, which in standard unit means what? 10 times 10 raised power minus 3 amps. So the next parameter here has an internal resistance of 0.5 ohms. That's small r. Resistance of the galvanometer is 0.5 ohms. Then calculate the resistance of the shunt required to adapt it to read up to 3 amps. So ammeter reading, which is I, that's the range, the value, the range of value, or should I say the value of current we want it to read up to. The highest value of current we want it to read up to is 3 amps, or you say ammeter reading 3 amps. So we have to find what? Calculate the resistance, that's the shunt. That means the resistance connected in parallel to the galvanometer. So what is the value of such resistor that we're going to connect in parallel for our ammeter to be able to read up to 3 amps? So I could just write out the formula here that R will be equals to what? Galvanometer current times its internal resistance divided by the ammeter reading minus the galvanometer current. This is the formula, and we already described how we get to this formula in one of our videos on how to convert a galvanometer to ammeter. You can check it up. So let's substitute. This will be equals to our I subscript G is 10 times 10 raised power minus 3 times R. Our R is 0.5. 0.5 is 1 over 2. Okay, divided by our I is 3 minus I subscript G, which is 0.5, or still a half. Sorry, our I subscript G, that is a mistake there. Our I subscript G is 10 milliamps. That's 10 times 10 raised power minus 3. So if you keep doing this, these 2 here will cancel this 10 here 5 times. So you have 5 times 10 raised power minus 3 divided by 3 minus, here what you have here is 10 divided by 1000. 10 raised power minus 3, 10 times 10 raised power minus 3 is the same as 10 divided by 1000. So which is 1 divided by 100. So this will be equals to 5 times 10 raised per minus 3 divided by 3 minus 1 over 10, 1 over 100 is equivalent to 0.01. So 3 minus 0.01. So 3 minus that this is 5 times 10 raised power of minus 3 divided by 2.99. 3 minus that will give you 2.99. And then if you do 5 divided by 2.99, so if you do 5 divided by 2.99, you will have okay, let me write it down here. You have 1.6722 dot dot dot. Then remember, we still have times 10 raised power of what? Minus 3. Remember, on this numerator. So this divided by 1000 or times 10 raised power minus 3 will give you 0, give you 0 point, how many, okay, give you 0.001672, which is approximately 0.00167 ohms. Or you can choose to leave it in standard form, which is what? 1.67 times 10 raised to the power of what? Minus 3 ohms. So the value of our shunt resistor equals to 1.67 times 10 raised to the power minus 3, or you say 0.00167 ohms. Thank you. Then on galvanometer, it says a galvanometer of internal resistance 50 ohm and full scale deflection of 20 milliamps is converted into a voltmeter by connecting a resistor of resistance 1950 ohms in series to it. Calculate the maximum voltage that can be read by the voltmeter. Okay, let's quickly do that. Don't mind how lengthy the write-up is, it's still the same basic principle and understanding. So as usual, let's start listing out our parameters. Governor with internal resistance. Okay, internal resistance R equals to 50 ohms. What other parameter? Full scale deflection. That's the galvanometer current. I subscript G equals to 20 milliamps. In which in the standard unit that would be what? 20 times 10 raised per minus 3 amps. So the next parameter converted by connecting a resistor of resistance. So the multiplier resistor or the multiplier or the resistor current series is what? 1950 ohm. So we are to calculate the maximum voltage that can be read by the voltmeter. That's V, that voltmeter reading. That's what we are to calculate. So you recall that we've already done analysis on how to convert galvanometer to a voltmeter in one of our videos. Is on the description, the link to the video. So let's do this. V voltmeter reading is equal to what? Galvanometer current into what? R plus small letter r. That's external shunt plus what? Internal resistance. And since V is what we are looking for, there is no need to do subject of formula because V here is already the subject of the formula. So all we have to do is now substitute our parameters. So I is 20 times 10. I subscript G is 20 times 10 raised power minus 3, open bracket. R is 1,950 plus small letter r, which is 50, which is 50. So if we continue to process that, we having this will be 20 times 10 raised power minus 3. That plus that will give you 2,000. So which equals to 20 times 10 raised power minus 3 times 2 times 10 raised power 3. 2,000 is the same thing as 2 times 10 raised power 3, or to say 2 times 1,000. Okay, so that 10 raised power minus 3, according to law of indices, will cancel 10 raised power 3. So we're now left with 20 times 2, which equals to 40 volts. So therefore, the maximum voltage our voltmeter can read is what? 40 volts. Thank you. Okay, question. It says, which of the following factors will increase the sensitivity of a moving coil meter? A. Strong spring. B. Low number of turns. C. Small area of coil. And D. Soft iron core. Which one do you think will be the answer there? So now for the sensitivity, or we say the force exerted, on the spring is equals to the number of turns times the magnetic field, that's the strength of the magnetic field, times the current through the conductor, the length of the conductor, and sine of the angle. So what this formula represents is that increase in number of turns will increase the sensitivity, increase in the magnetic field will increase the sensitivity, increase in current will increase the sensitivity. The increase in length of the conductor will increase the sensitivity. If the sine of the angle here is, if it is sine 90 here, which is 1, it will increase it. Anything other than sine 90 or 90 degrees will not yield that. So now our first option is strong spring. No, strong spring is not even among what we are saying. Strong spring will reduce the sensitivity because the strong spring will oppose the movement of the coil. It will resist it more. It will even reduce the sensitivity. So on B, low number of turns. No, if the number of turns is low, the sensitivity will not increase. The number of turns needs to be high. Small area of coil. No, area need to be large. Area of the coil need to be large. And then D, soft iron core. Due to the theory of electromagnetism, when you use, like in transformers, the reason we use the soft iron core is to increase the magnetic field generated by the coils. So we normally use soft iron core to increase the magnetic field. So soft iron core will increase B here, will increase the magnetic field. So the option I will go for is D. Thank you. take this question, WAEC 2001 on galvanometer. A galvanometer with a full-scale deflection of 1.5 times 10 raised to power minus 3 amps has a resistance of 50 ohms. Determine the resistance required to convert it to a voltmeter reading up to 1.5 volts. So let's quickly do that. Now we have to write out our parameters first. The first parameter here is a full scale deflection of that amps. That is galvanometer current. That's the current that will make it go full scale deflection. Is what? 1.5 times 10 raised to the power of minus 3 amps galvanometer current. So the next one has a resistance of 50 ohms. That resistance is the galvanometer internal resistance represented by small letter r equals to what? 50 ohms. Then say determine the resistance required to convert it to a voltmeter reading up to 1.5 volts. Okay, that's voltmeter reading 1.5 volts. So they say determine the resistance required. That's the external resistor, or you call it the multiplier. What we mean by multiplier is the resistor connected in series with the galvanometer, so that it can extend the range of voltage or can increase the voltage needed to give it a full scale deflection. So we are looking for big R. So if this is your galvanometer at full scale, you have to connect a multiplier, or you say a resistor, in series with it. So this is the resistor they say we should find. Here represent internal resistance of the galvanometer, while here is a I subscript G. So it is R that we're looking for. So recall from the relationship on how to convert a galvanometer to voltmeter. Voltmeter reading equals to what? Galvanometer current into multiplier plus internal resistance of the galvanometer. Then from here we are to make big R, since is the one we are looking for, the subject of the formula. Big R will be equals to a voltmeter reading divided by galvanometer current minus the internal resistance. So if we substitute into that, voltmeter reading is 1.5 divided by that, which is another 1.5 times 10 raised to power minus 3, then minus R. R is 50. R is 50. So if we process that, 1.5 will cancel 1.5, and 10 raised to power minus 3. If you take it to the numerator, it becomes 10 raised to power 3. So we have 10 raised to power 3 minus 50. 10 raised to power 3 is 1000. 1000 minus 50. 1000 minus 50 is 950 ohms. So the resistance required to make the galvanometer to read a voltage up to 1.5 volts is 950 ohms resistance. So if you connect a resistor of 950 ohms, you extend the range of the voltage the galvanometer to read, it will be able to read up to 1.5 volts. So that is the answer. Thank you. Question 1996 on galvanometer. It says, the diagram below illustrates the conversion of a galvanometer of resistance 2 ohms to an ammeter. The galvanometer gives a full-scale deflection for a current of 10 milliamps. Calculate the value of R. Okay, let's quickly do that. As usual, we write out our parameters. The first parameter there is the internal resistance of the galvanometer. That's small r equals to 2 ohm. And then the galvanometer give a full scale deflection for a current of that's galvanometer current equals to 10 milliamps. And if you convert that to the standard unit, which is amps, that will be 10 times 10 raised power minus 3 amps. Then they say we should calculate the value of R. And R here on the diagram represents the shunt. Shunt means resistance connected in parallel to another, a resistor connected in parallel to another device. So we call that a shunt. So we have to calculate this. And then from the diagram, there's one more parameter that we can pick, the ammeter reading. That's I. Ammeter reading is, from the diagram, 10 amps. So having taken down our parameters, let's solve that. So you recall that R, from the derivation of conversion of galvanometer to ammeter, we have done it in a video which is in the link in the description. So we derived that R, big R, equals to what? Galvanometer current times galvanometer resistance divided by ammeter reading current minus galvanometer current. So we substitute that to get what we want. I subscript G is 10 times 10 raised power minus 3 times R. Our small r is 2 times 2 divided by I minus I subscript G. Our I is 10. I subscript G is 10 times 10 raised power minus 3. So if we do this, 2 times 10 is 20. 20 times 10 raised power minus 3 divided by 10 minus 10 times 10 raised power minus 3 is the same thing as 10 divided by 1000. Because 10 raised power minus 3, according to law of indices, is 1 over 1000. So it's like 10 times 1 over 1000. So this will cancel that. This will cancel that. So we proceed. So our R equals to 20 times 10 raised power minus 3 divided by 10 minus what is left here is 1 over 100, which is equals to 20 times 10 raised power minus 3 divided by 10 minus 0.01. 10 minus 0.01 equals to, this will be 20 minus 3 divided by, this will be 9.99. So if we do 20 divided by 9.99, 20 divided by, you have approximately 2. What you have is 2.002. Then times 10 raised to the power of minus 3 ohms. So that's the value. This is in standard form. So if you approximate this to the nearest whole number, that will be 2 times 10 raised to the power minus 3 ohms. So the value of R is what? 2 times 10 raised to the power minus 3 ohms. Thank you. 95. on galvanometer voltmeter. It says a moving coil meter with an internal resistance of 100 ohm has a full scale deflection when a current of 10 milliamps flows through it. What value of resistance would convert it to read 10 volts at full scale deflection? So let's quickly do that. As usual, we are going to write our parameter. The first one is internal resistance of the galvanometer R equals to 100 ohms. The next one is scale deflection when a current of that is our galvanometer current, I subscript G equals to 10 milliamps, then convert it to amps. That will be 10 times 10 raised to the power of minus 3 amps. Okay, flows through it. What value of resistance would convert it to read 10 volt at full scale deflection? Okay, that means our voltmeter reading is what? 10 volts. That's the voltage, the highest voltage we want the voltmeter to be able to read. So, what are we to calculate now? The resistance that will convert it, that's the big resistance, or we call it multiplier. I mean the resistance that we're going to connect in series with the galvanometer so that it can read up to 10 volts. So now you recall that V voltmeter reading equals to what? Galvanometer current times, you open bracket, multiplier resistance plus internal resistance of the galvanometer. So if you make big R the subject, in which that's the one we are looking for, this will be V over I subscript G minus internal resistance. So we're going to substitute our parameters to see what our answer will be. So our R equals to, our V is 10 volts, 10. Our I subscript G is 10 times 10 raised to the power of minus 3. Our R is 100 ohms, 100. So this equals to 10 will cancel 10 one time. So at the numerator, the what will be left, it will be 1 times 10. If you take this 10 raised to the power minus 3 to the numerator, it becomes 10 raised to the power of 3 according to law of indices. 10 minus 100. This will be equals to 10 raised to the power of 3 minus 100. And 10 raised to the power of 3 is what? 1000 minus 100, which equals to 900 ohms. So the resistance that we're going to connect in series with the galvanometer for it to be able to read up to 10 volts will be what? 900 ohms resistor. Thank you.